Every single thing ChatGPT has ever said to anyone on Earth traces back to a caveman scratching lines into a piece of bone. Not metaphorically, literally. That's where the chain starts. And if civilization collapsed tonight, and you had to rebuild artificial intelligence from absolute zero, you wouldn't start with code, or computers, or even electricity. You'd start with the number 2. Around 30,000 years ago, a human carved 29 notches into a baboon's fibula and left it in a cave in Swaziland. Archaeologists found it in 1973 and called it the Lubombo bone, the oldest known mathematical object in human history. That person wasn't doing algebra. They were doing something far more radical. They were agreeing that a mark on a bone meant the same thing every time you looked at it. That one agreement, that symbols can represent fixed quantities, is the entire foundation everything else is built on. No math, no AI. And calculators don't grow on calculator trees. Before you get anywhere close to artificial intelligence, every civilization that ever tried had to pass through the same narrow gate. They had to formalize counting into arithmetic, arithmetic into algebra, and algebra into a shared symbolic language that strangers could use without misunderstanding each other. The ancient Babylonians cracked this around 4,000 years ago, using a base 60 number system so precise that we still divide hours into 60 minutes because of them. The question nobody thinks to ask is, what if humanity had never agreed that 2 always means 2? What if every tribe counted differently and refused to reconcile? The answer is no telescopes, no navigation, no physics, and certainly no computers. Math isn't a subject you study. It's the operating system the physical world runs on, and the first thing you'd need to reinstall. Now you have numbers. But a computer can't use them, because a computer doesn't understand numbers the way you do. In the early 1940s, mathematician Claude Shannon proved something strange: all information, every word, every image, every sound, can be expressed using exactly 2 symbols. Not 10, not 26, just 2, on and off, 1 and 0. Every movie you've ever watched, every song you've streamed, every reply ChatGPT has ever typed, secretly underneath all of it, it's just billions of zeros and ones switching states billions of times per second. This isn't a simplification, this is exactly what's happening. Binary works because it maps perfectly onto physical reality. A switch is either open or closed. A wire either carries voltage or it doesn't. A magnetic domain points either up or down. The universe gave us a 2-symbol alphabet, and Shannon proved we didn't need a bigger one. But here's the open question that should be nagging at you. How do 2 symbols build an entire internet? The answer is the transistor. And this is where things get genuinely strange. In 1947, 3 physicists at Bell Labs, William Shockley, John Bardeen, and Walter Brattain, assembled a tiny device from germanium and gold foil on a wooden base, barely larger than a fingertip. It could amplify an electrical signal and, crucially, switch it on or off using another, much smaller signal. They called it the transistor, and it was, without exaggeration, the most consequential invention of the 20th century. Today's chips pack over 100 billion transistors into a space the size of a postage stamp, each one smaller than a coronavirus particle. Hire 100 billion microscopic light switch operators, give them a clock that ticks 1 billion times per second, and you start to see why the math scales. One transistor does nothing useful. A few, wired together cleverly, make a logic gate that can ask, is this true or false? A few hundred logic gates make an adder that adds numbers, and billions of those, stacked, layered, clocked together, become something that can run Netflix. That said, the transistor alone isn't a computer, it's a component. To build a computer, you need 3 things layered on top of each other: a processor that does arithmetic and makes decisions, memory that holds data while the processor works, and storage that remembers data even when the power's off. The first true programmable electronic computer, ENIAC, built in 1945 at the University of Pennsylvania, weighed 30 tons, filled an entire room, and consumed as much electricity as a small town. It could perform 5,000 additions per second. Your phone does 500 billion, but strip away the speed and the scale, and you're still looking at the same machine ENIAC was, an absurdly expensive calculator that can only do exactly what it's told. Which raises the most uncomfortable question about computers: is any of this actually intelligent, or is it just unbelievably fast at being dumb? The honest answer, for a very long time, was the second one. That's where programming came in. A program is a list of instructions written by a human that tells a completely instruction-dependent machine every single thing it needs to do. The machine has no judgment, no intuition, no context. Computers are the smartest idiots alive. They'll do precisely what you say, even when it's not remotely what you meant. Early programmers had to write instructions in binary by hand. By the 1950s, languages like Fortran let programmers write something closer to readable English, which the compiler translated down to machine code. By the 1980s, software could run spreadsheets, simulate physical systems, route phone calls. Still, every behavior was explicitly defined in advance. The machine never surprised you. And then someone asked the question that changed everything. What happens the moment you stop giving instructions? In 1959, IBM researcher Arthur Samuel built a program that played checkers and improved at it without being told how to improve. It played thousands of games against itself, tracked which moves led to wins, and gradually got better. Samuel called this machine learning. This was the exact moment machines stopped obeying and started guessing. Instead of a programmer writing rules for every situation, the machine learned the rules from examples. Feed it 1,000 photos labeled cat and 1,000 labeled not cat, and it figures out on its own what distinguishes the two, without anyone explaining fur, ears, or whiskers. The catch is that nobody can fully explain how it figured it out. That unease sits at the center of everything that came after. Because once you can learn from examples, the question becomes how deep can that learning go? The answer arrived in the form of something modeled, very loosely, on the human brain. In 1958, Frank Rosenblatt at Cornell built the perceptron, an artificial neuron that could take inputs, weight them, and output a decision. One artificial neuron is about as smart as one Lego brick on the floor, individually, completely useless. But stack enough layers of them together, connect them in the right way, and the structure that emerges can do something remarkable. It can learn to represent concepts, not just catves, not cat, anxiety, irony. The feeling a sentence is grammatically wrong before you can explain why. These layered structures are called neural networks, and in the 2000s, a confluence of three things turbocharged the massive datasets from the internet. Graphics processing units originally designed for video games that turned out to be perfect for matrix math, and researchers like Geoffrey Hinton, Yann LeCun, and Yoshua Bengio who kept pushing when most of the field had given up. Then the training happened. Modern AI doesn't just peak at a few examples. GPT-4, released in 2023, was trained on text estimated at trillions of tokens, scraped from books, websites, scientific papers, forums, and decades of digitized human thought. The training process ran for months across thousands of specialized processors, consuming enough electricity to power a small city. Why does an AI need to read almost the entire internet just to sound smart? Because it isn't memorizing the internet, it's learning to predict it. Every large language model, GPT, Gemini, Claude, works on one core trick given everything that came before. What word comes next? That's it. That's the whole mechanism. There's no tiny person inside ChatGPT typing your answers. There's a mathematical function, enormous, incomprehensible in scale, that has been tuned across trillions of examples to predict which token follows which, so accurately that the predictions read like understanding. The disturbing question isn't whether it's faking comprehension. The disturbing question is whether understanding and very accurate prediction are actually different things. So here's the full chain, laid out without the hype. Counting became arithmetic. Arithmetic became algebra. Algebra enabled logic. Logic was encoded in binary. Binary was switched by transistors. Transistors were arranged into computers. Computers ran programs. Programs learned from data. Learned systems grew into neural networks. And neural networks trained on the written record of human civilization became something that can hold a conversation, write a poem, and diagnose a disease from an X-ray. AI isn't one invention. It's thousands of inventions, each one built on the last, stretching back 30,000 years to a person in a cave with a bone and a sharp rock. If civilization reset tomorrow, the hardest step to rebuild wouldn't be the neural network. It wouldn't even be the transistor. It would be the first one, getting every surviving human to agree, again, that the same symbol always means the same thing. Everything else follows from that.